Hi, everybody. Thanks so much for joining today and welcome to Open for Live. Open for Live is an interactive show sharing production case studies, open source demos, industry conversations, and the latest updates from the global open source infrastructure community. This show is made possible by the support of our valued members, so thank you so much to them. My name is Triva, joined with my co-host Doggo, and I will be your host today. Well, we both will. We're streaming live on YouTube and LinkedIn, and we'll be answering your questions during a Q&A period at the end of the show. So feel free to drop any questions in the comments section, and we'll answer as many as we can. Today, we're here to talk about confidential containers and Kata containers, the hot container runtimes that offer the security of a virtual machine with the speed of a container. And in today's episode, Zvonko Kaiser from NVIDIA will be sharing insights on confidential containers specifically, the security challenges in containerization, and how sandbox environments have evolved with the use of Kata containers. Welcome, Zvonko. You want to tell us a little bit about yourself?
Sure. Hello, everyone. My name is Zvonko Kaiser. I'm with NVIDIA from the Cloud Native team. Our team is mostly responsible for all things related to cloud native technologies here at NVIDIA, and we are responsible for enabling the GPU in containers and Kubernetes. Lastly, I've been more focused on Kata and confidential computing, which also resulted in working with confidential containers.
Neat. Awesome. So for the folks in the audience that aren't familiar with Kata or Coco, if you were to explain either or both of those technologies to them, say if they were just like strictly OpenStack, how would you explain it to them?
Well, we would firstly need to start with what a container is. And simply speaking, a container is nothing else than a process with some specific views on resources, which are separated by namespaces. So every container has a specific view, let's say, on PIDs, on mounts, and other resources like CPUs. The container is, simply speaking, a packaging format for user space applications. And this container can then be run, let's say, on a Kubernetes platform for scheduling and stuff like that. So the other technology that we need to explain is here virtual machines, which is a virtualization technology where you're essentially running a separate system inside of another system. So what Kata is essentially using a container, packaging it in a VM, and running this container in a VM as a second line defense of isolation, so that because many of the containers have the problem that they're sharing the very same kernel, and container breakouts can take over the complete node and even a complete cluster. So what makes Kata special is that you're using or running a container inside of a VM as a second line of defense. So if you're worried about, let's say, container breakouts, you can use Kata to isolate it in a VM. And if you're worried about VM breakouts, you can even extend this to use a confidential container, which uses encryption technology to protect the VM on the host from the infrastructure, from the administrator, or from other VMs.
Neat. So that would be for Coco trusted execution environments?
Yes, trusted execution environments, which is essentially a hardware technology, which is really not new, but it evolved to a more acceptable solutions in the last year with AMD SMP or Intel TDX. On ARM, we had TrustZone. And if we look at mobile devices, every mobile device had trusted execution environments for paying systems or vaults where data which is confidential is secured. And along those lines, we also have sandbox environments that were evolving from time to time, especially because if you're looking at containers, you want to fortify the isolation between the container runtime and the kernel. So there were things like unikernels or IBM Nabla, which is essentially a unikernel as a process to reduce the syscall which is essentially the attack surface between a container and the host. And then we have things like Gvisor, KubeVirt, Firecracker, and of course Kata. And all of those technologies are essentially fortifying the isolation between the container runtime and the host operating system. They're doing it in different ways. If you're looking at Gvisor or IBM Nabla, they are filtering on syscalls, whereas solutions like Firecracker, KubeVirt, and Kata are relying on hardware virtualization, accelerated hardware virtualization.
Awesome. Neat. So I heard you mention Gvisor, and that was a question that came up during KubeCon. Sorry to throw this one out like randomly, but I'm just curious. Can you run Kata containers in Windows with Gvisor? And if not, is that on the roadmap?
Kata containers in Gvisor
on Windows?
No.
We'll come back to that question.
Yeah, because Gvisor is essentially a user space kernel, and it's process-based isolation, and you cannot run a VM in Gvisor. So it's just process isolation, and this does not fit together as technologies.
Okay. Thank you for answering that. I'm sorry for throwing that out randomly, but it just popped into my head.
No worries.
Awesome, but thank you for playing along. Yeah, so I kind of did this myself at the beginning in the intro. There's a lot of crossover between the Kata containers and confidential containers communities. So are they basically the same project, or are there some key differences between Kata and Coco that you could point out, or are they just like peanut butter and jelly, like they're partner projects? Or
you can say that they are partner projects, but for me, confidential containers is more of a umbrella term. Because the backbone of confidential containers is really Kata. And in confidential environments, there are several other steps that you want to after you're spinning up your VM and your container. And such things are like attestation. And confidential containers provides tools and guest components for Kata to do attestation. And attestation is simply the verification if a system is running with the proper software and proper versions that you are expecting. So essentially, it's a simple pipeline of, okay, I'm expecting specific versions of the software. Does my trusted compute base, which is Kata plus VM image, kernel and stuff, are they in the right version? And then give me back a report on which I can decide if I want to deploy my workload or not. So essentially, in short terms, Kata containers is confidential containers is Kata plus some attestation components that we need to run confidential containers. And the nice thing is about Kata and confidential containers is we have a broad support on many hypervisors, and we are the only software that supports all major trusted execution environments, be it AMD SMP, Intel TDX, ARM CCA support is coming up, and RISC-V is also something that we are working on.
Oh, that's amazing. That's great, because part of the draw for myself, at least, to Kata containers was how platform agnostic it is. So it's exciting to hear that is being expanded to more agnosticity. I'm not even sure if that's a word, but I used it. So, all right, go ahead.
No, nothing.
Okay. So another question that comes up fairly often, or very often, is what's the difference between Kata containers and Docker?
If you're looking at it at a high level, then there's no difference, because it's essentially a container runtime which runs a container on a specific host. But then looking deeper, you are seeing that Kata uses virtualization in the middle. And Docker is running a container on the bare metal without any virtualization. Well, you can say that the user space packaging is some kind of operating system virtualization, because you can take a container and run it on every operating system, be it Ubuntu or Red Hat or whatever else, right? So, but as a Kata container, you still have the virtualization middleware in between where the VM is plugged in. The nice thing about Kata is, and also what draw us to Kata is that Kata is CNI, CRI, CSI compatible, meaning a user running a Kata container or Docker container or any container image is completely transparent to him. All the commands that you're used to, like nerdctl docker, are just working with Kata or any other Docker container. And the same applies also to Kubernetes. Anyone using kubectl or kubectl, I don't know which pronunciation is the right one, but you will not see any major, or you will not see any differences between a pod which is running with the Kata runtime and a pod which is running with containerd.
Fascinating. Okay. Thank you so much for the in-depth answer. I don't even want to go into how I've been explaining the differences, but that clears it up significantly. So thank you for that. All right. So I heard you mention, so first off, my question, or my first question is, what is your favorite operating system? Because that is very important.
That would be Linux, and this is really broad. So I'm telling you also my favorite distribution, which is Gentoo. I've been using Gentoo on and off since the beginning when it was firstly developed at IBM many years ago. But yeah, I'm doing everything on Linux with Gentoo, and it works pleasantly fine compared to 15 years ago.
That is hardcore. Gentoo is serious. Wow. Okay. And I phrased that question wrong. I should have assumed that it was going to be Linux, but yeah, phrase it up. Yeah, distro. That's cool. Second favorite, because Gentoo, just in case that's a little bit too. Okay. Another question: if someone wanted to get into Linux, using Linux as their primary operating system, where would you recommend that they start? Like most folks start with Ubuntu, but they may not be, I don't know, comfortable with dev systems. So what would you recommend?
Something which is easy installable and maintainable. And then from there, if they are gaining more and more experience, they will automatically get into things where, okay, I just want to know everything about Linux. Then somebody's looking at Arch Linux or Gentoo or Manjaro Linux or stuff like that. So I think they are going to hop between distributions anyway, because they are maybe getting fed up how Ubuntu is doing things. Then they maybe switch to Fedora, and then they're fed up with RPMs, and there are always reasons to switch from distribution to distribution. But as a starting point, use something that it's easy installable. When I started, I wiped out almost 6 gigabytes of MP3 back in 2003 or 4 because I didn't know the difference between a logical partition and a primary partition. So yeah, it really depends. So use a blank hard drive to experiment. Do not use it on your production data.
Yes, very smart. Very true. Awesome. Okay, so let's get back on topic. We're here to talk about Kata, not about distros. So what's the difference between a GPU container and like a regular container or a vanilla container? I'm not even sure how to phrase that. And what would be some use cases for sticking with a GPU container?
There's no really a difference between a GPU and a regular container. You could also call a regular container a CPU container because you are doing the number crunching on the CPU. But in the end, a container relies, so it has the user space part, and then it relies on some hardware that you are using. And in one case, you're using just a CPU to do some number crunching, and in the other case, you are using just a GPU to do number crunching. So from the technology point of view, there's no really difference between a GPU and a CPU. The only thing may be only that you are using different software to access different accelerators, like in the case of the GPU or the NVIDIA GPU, you would use CUDA. And for the CPU, you can use like almost any language. You don't have to use any middleware or any libraries to, well, you may use other libraries if you want to do accelerated computing using SIMD instructions So in the HPC use case, you have often optimized libraries on this. But in the end, a GPU container does not really is a difference between a CPU and a GPU container.
Fascinating. Okay. So when I think about a CPU, I think about the little thinking rock that you put on your motherboard, and a GPU, that's like a graphics card, right? Is that like an accurate way to think of each of those things?
If you look at the GPU, is you can imagine a GPU having thousands of those little CPUs. And you often run algorithms that are embarrassingly parallel, where each of the data does not is completely independent of the neighboring data. So imagine you have a picture and you have 1000 pixels, and you want to shift or to do anti-aliasing or do some number crunching on a specific pixel to move it from red shift to a green shift in color, right? On the CPU, you would go for each pixel. Well, depends if the CPU has hyperthreading or not. But essentially, you would go for each pixel, you would do the calculation for each pixel sequentially. On the GPU, you could do this in parallel for every pixel at the same time, which is called SPMD, which is single program, multiple data points. So depending on the size of your GPU, you are very fast on doing the calculations, because those calculations can be then massively parallel of thousands of little, let's call them CPU cores. The architecture is different because the memory hierarchy is different, but essentially thousands of small CPUs working simultaneously on each data point.
Okay. So I was completely wrong, but that's fascinating. I didn't realize how or I hadn't really given a whole lot of thought to how complex a GPU would be. But thank you for like a little bit more explanation. Cool. So yeah, I heard you mention something about sandbox environments a little bit earlier. So not even going to go into my explanation about what I think about when I hear the word sandbox, like usually like a test environment. Could you explain to us a little bit of the history of sandbox environments in Kata and Coco and the importance of them? Because I'm familiar with Dragon Ball sandbox, but I guess I would like to hear more, and the audience certainly would like to hear a little bit more about it.
Right. As I mentioned before, people were always looking into fortifying the isolation between a container runtime and the host operating system. And way back, people were thinking about using unikernels, which is essentially running workloads merged with a kernel in the same memory space, so that you cannot essentially change the workload because it's running as a simple kernel, and this is the only thing that you can run, stripped down to the bare minimum without any additional libraries. So this simple unikernel was only running the workload which was compiled with the kernel libraries and the kernel. So, and what IBM did is using this unikernels as the scheduling unit, and built the project IBM Nabla, which is essentially a small unikernel running as a process. Additionally to this unikernel, which is doing only one thing at a time, they introduced a layer between the container runtime they're building to running those unikernels as a container on this system, to filter on syscalls. So the kernel had a limited attack surface because the syscalls are essentially the things that are providing the container functionality. And if you limit your unikernel to a very, very small set of syskernels, your threat or your attack vector simplifies a lot. So it's always the goal to run as less as possible code and interfaces between a container runtime and the host operating system. And this IBM Nabla OCI compatible runtime system was run NNC, and they even had some Kubernetes adoption there. So you could run a unikernel as a process inside, as a container inside of Kubernetes, and also on bare metal. And there was also Google for their workloads and services. They implemented like Gvisor, which is a small kernel running in user space. It's not tied only to one unikernel or one workload. They want to run any workload. And Gvisor essentially re-implements all system calls in user space so that they can do filtering or more advanced functions and security on those syscalls as well. So what they're doing is reducing again the attack surface between the container runtime and the host operating system with their own implementation of system calls. Not all system calls are implemented, and a reimplementation of syscall can take also some induce some overhead if you have syscall intensive applications like I/O, storage, networking. So people were also looking into other ways to fortify this isolation with hardware support. And the logical solution to that after that was to use a VM as a intermediate layer to protect isolation with the help of hardware accelerated instructions. So, and there are two major projects that I know of which are used. One is KubeVirt and the other one is Container. The difference between KubeVirt and Kata is that KubeVirt is running a VM in a pod and Kata is running a pod in a VM. If you're looking at KubeVirt, it not always fits in nicely into the cloud native space because you cannot run easily a container inside of KubeVirt on a Kubernetes cluster. You always have to bake your own VMI image, or you're installing a Docker runtime inside of your KubeVirt VM, which is running in a pod. But that still does not give you the nice feeling of really using like kubectl to execute this very container inside of KubeVirt. Whereas in Kata, with the VM and all the compatible CNI, CRI, CSI interfaces that I mentioned before, it's a completely transparent experience on Kubernetes or on any other container runtime. And there are for an AWS, for example, also went the path of virtualization. They built Firecracker, which is a micro virtual machine. It's a minimal operating system and a minimal set of emulated devices. Again, an intermediate layer with virtualization to protect the hardware from containers and other attack vectors. And you mentioned Dragon Ball before. So this is also a new micro VM that the upstream community is a micro VMM that the upstream community is working on, completely implemented in Rust, and the Rust runtime, which goes hand in hand with that, is also one thing that the upstream community is working on. So even they're reducing the attack surface and using a language which is by default more secure, let's say like C++, Go, or any other language.
Awesome. I was just about to ask you a little bit more about the Rustification that's happening with Kata Containers. It started at the 3.0.0 release, correct?
Yeah, something like that, yeah.
Awesome. So aside from the obvious, what was it that inspired the translation or the transition from Golang to Rust for Kata Containers? And is that going to be carried over into Coco?
So Rust by default is a more secure language than Go.
Mm-hmm.
I'm not going too deep into the details of Rust versus Go because I'm going to start a flame war here. But people can read it up, and from the Rust perspective, it's more of has more functional features, functional programming features that people are using to implement stuff. which also makes it easier to implement, like, let's say, threaded programs if you're using functional programming constructs. So a lot of, if people are familiar with Haskell and know what a monad is, they're going to see a lot of similarities between the functional programming language Haskell and Rust. And there are a lot of papers describing how functional programming can help in security, because you don't have no side effects. Well, you can introduce in Rust also side effects, but if you're removing side effects, you can program software more performant and more secure than in any other language.
Fascinating. Okay. So some of the during the mentorship program, some of the, I guess, like pushback we received, some of the feedback we received was that Golang was the more user approachable version, or the more user approachable code, versus Rust, which was a lot more complex, but was a lot powerful. So yeah, I guess that kind of reinforces that. And please don't yell at me, Rustaceans or Gophers. I'm just the messenger. Awesome. Okay. So another question that comes up fairly frequently that I'm also fascinated by is Kata and Coco and its use in artificial intelligence and machine language. Back at Open Infra Summit in, I think it was June, back in Vancouver, a couple of Kata herders gave a demo where they showed where they were running a GPT bot on Kata containers, which was super fascinating. I was so thrilled by it. But anyway, could you tell us a little bit more about, I guess, current and possibly future implementations or integrations of AI and ML in Kata containers and or confidential containers?
Sure. If we are looking, if you're looking at the at AI/ML, there are three main pipelines that are executed. One is data exploration, second one is training, and third is inferencing. And in each of those pipelines, you have personas that may have confidential data that you want to protect. My example to go is, imagine you have a model trained on patients' data that can detect, let's say, cancer, lung cancer or something like that. So if you're doing like this training, you want to protect first the patient's data, because you don't want that any infrastructure administrator employees has access to this patient data. And then secondly, if you have the model trained, this is IP, this is intellectual property that you want to make money off, or even with the model, people could be able to deduce confidential data from exercising, let's say, wrong inputs or malicious inputs. So you want to protect also the model when it's in use. So when you're doing inferencing, you want to protect the model. And then again, you are exercising inferencing with confidential data against this model. So you also want to protect all the data that's coming in and getting out. And this is where confidential containers can help. Protecting the model in use, protecting the data in use at any pipeline stage. And currently looking at like large language models, the inferencing pipeline is, well, simplified. It's a web front end talking against a API server, which talks then to a inferencing server and some vector database. All of those components can introduce entry points for an attacker to leak data or to do denial of service attacks. So we can use, let's say we are worried about container breakouts, so we can use Kata. And then I think about virtualization is that we can have more strict resource requirements or for each of those containers. So if we assign one CPU and only like half a gig of memory to a VM, even if the container breaks out, he will not get more resources than it gets from the VM. So this is a nice way to reduce to save resources on per container. And things or models or data running where we can extract confidential data, like the inferencing server with sophisticated attacks. There are a lot of papers out there how you can craft your inputs to extract confidential data. There needs to be also things like input and output validation, but you also want to protect the model against the infrastructure or your cloud provider or the administrator, stuff like that. So you have the inferencing server, and then you have oftentimes the vector database, which also, it's an abstract representation of the data sources that you're feeding, be it PDFs or any other input source that may be confidential, where attackers could also deduce some confidential data. So you want to run this vector database as well in a confidential environment. And this is where confidential containers come into play. So you can run, if it's really confidential, you can run, let's say, the vector database and your inferencing server inside a confidential container, and then the web front end and the API server maybe as a Kata container, because you want to constrain the resources that this container may have. And even if it breakouts, we still have virtualization as a second line of defense. And yeah, depending really on the threat model, you can cascade the technologies that you are using. One thing that I want to mention is also, if we're looking at KVM and QEMU, they are having the very same, I will not say the problem, but the challenge that they share the very same kernel. So a rogue QEMU VM can still do some harm on the other VMs because they're sharing the very same kernel. The same case with the containers. That's why we introduced virtualization inside of containers, so that we can run our own kernel inside of the VM, which makes it kernel and user space independent, which lets you also where updates to the kernel on the host will not really break the VM and the container inside running of the VM. So KVM is always, most of the time, seen as a type 1 and type 2 hypervisor, but it's not really a true type 1 hypervisor like Xen or the hypervisor that's running at VMware, where it's only running on bare metal, and you have different privilege levels, isolating the VMs more or better than, let's say, KVM and QEMU are doing that. So we are also looking upstream in enabling true type 1 hypervisors to have more control between the VMs, where we are not sharing resources.
Fascinating. Okay. So I guess that explains, or I was having flashbacks to when I used to work in public cloud and how much of a lifesaver Kata and Coco would have been dealing with noisy neighbors. It sounds like it would be a perfect solution for that type of environment. Cool. All right. So this is probably something I should have asked earlier in the conversation, but I was just wondering, you mentioned that you are a super duper principal engineer over at NVIDIA, and I'm assuming that is part of at least part of the reason why you're involved in Kata and Coco, because you are helping them to develop some type of awesome new implementation of Kata containers internally. Can you tell us a little bit about what you're doing? If not, then tell me shut up, I'm moving to something else.
No worries. I'm leading the Kata and confidential containers effort here at NVIDIA. And we are trying to introduce Kata and confidentials, or we are not trying, but we're doing it into products where we see that we need more isolation. And a little bit maybe to the history, how I came to Kata. We need to rewind the time at least 3 years ago, where we were mostly responsible, or where we are executing the cloud native enablement of the GPU. You may heard about the GPU operator, the networking operator, NFD, node feature discovery, where we are working very closely with Intel on it. So we had all those components to enable the GPU in a cloud native way in containers and Kubernetes. And at this time, we were also looking into isolation techniques. and how can we, bring more security and stability with the GPU to workloads that are confidential or sensitive to denial of service or theft or whatever else. So that's where we come upon looking into virtualization technologies like KubeVirt and Kata, but it fairly soon crystallized that the way to go, if you want to have a cloud native way of enabling a container with virtualized isolation, was Kata. As I mentioned before, it just fits in transparently into any Docker runtime, in any container runtime, be it Docker, Podman, CRI-O, Kubernetes with CRI-O, Kubernetes with Containerd. It just fits into transparently, and we essentially do not have to care about if we are which CSI driver we're using, what the CRI is, because in the end, Kata is really CNI, CSI, CRI compatible, and everything that we are using in Kubernetes just plugs in neatly with Kata containers. So I've been working the last 2 years very actively in Kata, where we added proper GPU support on it. So Kata had got GPU support. We also enabled vGPU, virtualized GPU support. So there are two ways of looking at it. vGPU can be used as a time slice. So each of those those chunks of the GPU is divided by time, or you have a more sophisticated split of virtualization of the GPU with MIG, which is essentially a hardware virtualization technology to split up the GPU in distinct compute units, where the compute capability and memory capabilities are fixed. You can think of it as a small virtual machine. So you can use the virtualized GPU also with MIG or with time sliced virtualization. So we added support for this as well. And to have more sophisticated use cases like GPU Direct RDMA or GPU Direct GDS, so for people not knowing what this is essentially a peer-to-peer communication on the PCI Express topology without going over the CPU, meaning a NIC to send out data and getting data in can talk directly to the GPU without ever touching the memory of the CPU, because this is a lot of performance drop if you need to go over the CPU. And for GPU Direct RDMA and GDS is GPU Direct accelerated storage. So the GPU can be fed in by a storage which is attached directly to the NIC. So the GPU is talking directly to the storage without ever touching the CPU. And for those more advanced use cases, what we added to Kata is the virtualization reference architecture, which essentially describes how you need to set up your PCI Express topology inside of Kata to make this kind of sophisticated use cases work. Not going into the details, but anyone who is interested can ping me. We can share the documentation on it, and that's what we're currently implementing. So the end goal is really to have such use cases running inside of Kata. And the nice effect of this was and is that I'm doing the implementation, the Go runtime, but with this pattern that we established here in Kata, anyone can implement this virtualization reference architecture and enable CUDA and GPU Direct support. And this is exactly what's currently happening. The runtime folks, who are doing the Rust implementations, they are following the steps that we outlined in the virtualization reference architecture and implementing now GPU support in Dragon Ball. So without me doing a lot of work, but setting this pattern, they can implement it, or it can be implemented on any hypervisor, be it Dragon Ball, Firecracker, or whatever else. So they just need to apply all the lessons learned that we have, and they can implement it. So we are currently very actively working on getting GPU support in Dragon Ball.
Awesome. Cool. Thank you so much for the in-depth answer. All right. So we're doing pretty good on time, but I want to make sure that you have enough time to do the super exciting demo that is coming up. But I have one more quick question, or a couple of quick questions. So first off, I am wondering if Kata and Coco were the first open source projects that you got involved with, and if not, which project did you start out with? Or which project did you start out with first, and what led you over to the Kata Coco world? I mean, aside from the obvious that we're awesome. And then the second question would be for somebody out in the audience who's listening in and wants to get involved with open source something, anything. How would you recommend they get started? And also, what are some of the benefits that you have gotten from being involved in open source? Because a lot of people think, oh, I'm not doing all that work for free. Well, like, what's in it for me? But there's actually a ton of things in it for you, like including like, helping out the entire global community. But anyway, so that was a lot of questions and a lot of words. But yeah, how'd you get started with open source? How's it been benefiting you? And how would you recommend somebody get started?
So I need to think about that. What was my first open source project? Honestly, I don't know. What was the first open source project? There've been a lot, so I can really remember. I'm doing this job like for the last 12 years and always involved open source.
Cool.
But the very first project, I cannot remember, honestly. But the benefits would be, of course, from the confidential point of view, from confidential containers point of view, is that we are not providing security by obfuscation or by hiding anything. It's completely open. Everybody can take a look at the source code and exactly knows what's going on when executing Kata, and what's going to happen if you're doing like a GPU pass-through inside of a Kata. So compared to the cloud providers, you don't really know what's happening there because it's closed source.
Right.
They can do audits on it, but then again, who is auditing the auditor, and when are you stopping, and how are you going to make the claim that everything is secure?
We've investigated ourselves and determined there's been no wrongdoing.
Right. Yeah. we've done a good job, right? So yeah, the nice thing about open source is really you can see and verify what's going on. On the other side, it's a giving and taking, because you implement stuff that other people are going to need. Let's say GPU support in Kata, but there are a ton of other people that are implementing, let's say the attestation agent or key broker service that we need in confidential containers, which I don't have the knowledge about to implement it in the right way, but the other people can. So everybody is working to a common goal, and we are giving, let's say, GPU support, but getting like a ton of other things that we need in Kata or in confidential containers. And the other benefit, of course, is also that some say it's not a benefit, that there are so many eyes looking over your merge request or PRs that you are submitting. But in this process, you learn a lot about how to write your code in a way that's acceptable. You're learning a lot on the way from your first PR to your 100th PR. And I don't know how many PRs I have made in my career, but they are still always something to nag about because I've done something wrong, because I'm not seeing the forest of all the woods, right? And you're getting into touch with people you would never meet in the office or in persons, and this also opens up career opportunities, working with a diverse set of engineers which may refer you in the next time when there's an opening and stuff like that. So I remember like 15 years ago that no company was talking to the other. It was all closed source. Everybody is working with elbows. But in the open source community, everybody is trying to achieve a common goal.
Awesome. Awesome. I'm not sure where I was going to go with that, but yes, that is a fantastic answer. There are career benefits, but also like the difference is in points of view. I guess when you think about like a tech nerd, or from a tech nerd perspective, you wouldn't think that having those other perspectives would be important, but it is absolutely crucial, especially during that learning period, because we all learn how to do these things different types of ways. Some of us are self-taught, some of us have PhDs, and then there are the ones that are in between. So we can all learn something from one another, and open source is a great place to do that. Cool. Awesome. So last question, how would you recommend that someone get involved in an open source project? Like, say if they aren't confident in their tech skills, or if they don't know how to code, where would you recommend they get started? There are lots of other options, right?
Right. Today, every project like has at least a Slack channel. And they are like general channels where they could introduce yourself and ask where they can ask where they can help out. And there are a lot of maintainers looking at it and listening, where they can help to assign a simple PR to this person, and he can then, which is not time critical, which is not critical in the path of execution, where he could, let's say, update documentation, update some CI scripts, whatever else. So there's always some need to do some simple PRs on that. And then with time to time, people are getting more confident, and then they can take up more work. Or just look into the issues or PRs that are open there. If you think you can contribute anything, just tag you on the issue, ask questions about the issue. There's always someone listening, or reach out per Slack and start little and then iterate. It's a learning process. Many people need some time to get into open source and how it works, and that PRs are looked a lot with a lot of eyes and a lot of iterations, but you will get used to it. So start simple with a simple PR issue. Ask in the Slack channel if you can help out. Introduce yourself. Let's say someone has a PhD in formal methods, and we want to do formal verification of our runtime to see if we are doing everything wrong. I mean, this would be really nice, and people would be eager to see something like that. And then maintainers can create issues, also work with this person to create PRs and explain how we could do that.
Awesome. Really wish somebody with a PhD would chime in. That's awesome. Cool. Thanks so much for the answer. And also, I just want to jump in and say that, documentation is also a great place to jump in if you're not fans of code. Like, we always everybody needs people to write out docs and to try out stuff. Okay, so we are at 12 minutes. So if it is all right with you, would you like to jump into your demo?
Yeah, let's do a quick demo.
Okay.
It's not really sophisticated, but I just wanted to show the audience how, especially the lift and shift character of GPUs. Let me just see if this is coming up. There you go. Okay.
Awesome.
This is a node which has the drivers installed, and what I want to show here is, so this is a containerd runtime, that we can use any of those container frontends, be it nerdctl or Docker. It's the very same output. So we don't care if it's Docker, we don't care if it's nerdctl, we don't care if it's Podman. We can use the very same container and run it on any container runtime. And as well, the very same container or other containers can also be used to run it on confidential containers. So this was also one of the nice premises with Kata containers and confidential containers, that we are going to be able to run any workload unmodified on Kata and Coco. And what I have here is I'm just switching the runtime from containerd or any other runtime to Kata, and pass-throughing a VFIO device, which is attached to the GPU, into the VM. And yeah, don't be surprised that this takes a little bit longer. There's a lot of debugging enabled here, and we are code plugging the GPU. The GPU has a lot of memory. We are resetting the GPU at every invocation, because with each container startup, we want to make sure that the GPU is in a deterministic state, meaning that memory is wiped out, the settings are resetted, and the GPU, as said, has always a deterministic state to start from. And in a confidential environment, all those memory needs to be properly initialized, a function level reset is done, and once this container is up, we are going to see some commands where we can get us some information about where the GPU is running, if confidential mode is enabled, which CPU is running with this confidential mode, and that the GPU is set in ready state. What we are doing at startup inside of the VM, so our complete NVIDIA stack that I showed here, which is essentially running the NVIDIA container toolkit, which enables a GPU in the container. We took it, packaged it inside of the VM, and the VM is doing what the bare metal system is doing, so that we can use reusing our stack inside of the VM and have the same functionality in Kata. We can see that we are running here again our GPU. We can ask it if what compute mode is enabled. It's on. We can gather the CPU, which is an AMD SFE system. We can gather the GPU, which is also CC capable, and we can ask it about the status if it's ready. The reason for this is that we want to know if the configuration that we are running it, the vBIOS, the driver, and all the other things are in a state what we are expecting. And the VM will do internally an attestation. It will check the measured values that we're getting from the driver against a set of gold measurements, what we expect. And then we will get a report out that we can take a look in here, NVIDIA verifier. Oh, shoot. I think I took the wrong container. Sudo. Okay, there's something gone wrong. But anyway, I just wanted to show a file here showing that the attestation result was successful. But that is attestation was successful. We can see that the GPU is set in ready state. If attestation fails, if the vBIOS or the driver are in a wrong version, the VM will internally set the GPU to not ready, and the container will come up. But all the CUDA applications that you want to start on the GPU will just fail because the GPU is set in a not ready state. And from the container, there's no way to manipulate the GPU and set it in a state to a working state. It's all done on the VM level, completely isolated from the user. Attestation is done in the VM. Nothing is really running in the container. It should be completely transparent to the user without knowing the internal details if the GPU is set ready or not. This was a small demo just to showcasing the lift and shift character that we implemented with the GPUs. So take your container, run it on Docker, run it with nerdctl, run it with Podman, doesn't care. Take the same container, run it on Kata, or run it as a confidential container.
Awesome. Cool. Thanks for the demo. And that was very brave, I will say. So don't worry about anything that went wrong. It went like 99% smooth, because live demos, there's always something that explodes. So you did a great job. Thank you so much.
Thank you. Thank you.
All right. Awesome. So now we've got 5 minutes for Q&A. So, all right. First question, and I'm curious about this one myself as like a pie head. So if somebody didn't want to spend a whole lot of money, but they wanted to put their hands on Kata and Coco, would it be possible to run either / both on a small device like a Raspberry Pi?
Yeah, you can run Kata on any ARM system right now. So we added a lot of support, and especially we added also GPU support on ARM platforms. So you can run Kata on is it a G5D Metal instance in AWS, which is an ARM system with a GPU. And we are also enabled Kata on the NVIDIA ARM systems hardware that we are providing. You may have heard about the Grace Hopper chip, the super chip for HPC. So we are running already Kata on the Grace Hopper chip, and as well on the BF3, which is the DPU, the data processing unit, which is mainly responsible to provide infrastructure as a service. And you're running firewalls and stuff like that on that. And you may also want to isolate those services that are running in your infrastructure against each other. So yeah, we are also enabled like Kata on the BF3, and we should have proper and good support for all things related to ARM and GPUs. I am not aware of any system where Kata would not run today.
That's great news to hear.
On ARM and GPU, yeah.
Okay, awesome. Cool. Thanks for that. And there is a question coming in that is related. So on using GPUs, can it be split so multiple users can use parts of the GPU, or is it one-to-one? And that came from Daniel. Thanks, Daniel.
If you're doing a single GPU pass-through, it's one-to-one, right? It's a one user because one container. If you're doing vGPU, you can split up the GPU in multiple chunks, and each chunks can be allocated to a Kata container or VM. So it's 1 to n, and depending on the resource capability of the GPU, you can have a lot of profiles running, or a lot of chunks running on one single GPU. So it's a 1 to n relation.
Awesome. Says thank you. Thank you so much, Daniel. Another question came in. Sweet. So this one is there support for a live migration of Kata containers and confidential computing containers?
There is, so technically yes, because AMD SMP supports live migration for confidential containers. Intel TDX has also live migration capabilities coming up as well. So it should work, yes. But the only thing that we need to, the only thing that I would make a point is that GPUs currently do not have checkpointing support, or well, they have some checkpointing support, but it's not integrated into Kata and confidential containers, so that we can do checkpointing of GPUs, meaning that we can create a snapshot of the GPU and restore the state inside another VM. So with every accelerator that we are adding into the VM, we need to make sure that every hardware supports checkpointing. Otherwise, you can restore like the CPU and memory from AVM, but you may lose, let's say, the GPU and DPU state or NIC state. So all the components that are in the VM need to support that, as well as the trusted execution environments.
Awesome. Thanks for that. Sweet. Thank you, LinkedIn user, for sending such a great question. So I've got a question. So I'm just curious to know, I do not want to try it out myself, but I'm just curious. Can Kata containers and confidential compute containers be run in an air-gapped environment?
Yes. There shouldn't be any any problem to that because you can apply all those air-gapped mechanisms that you would use for your containers, like local image caching, or you're creating a local repository to store your images on this air-gapped environment. So you can use all of those technologies to create an air-gapped environment for Kata or for confidential containers. Since it's Kubernetes compatible, all those technologies would just work.
Nice. Awesome. Thanks for that. And we are at the hour. So this has been an amazing conversation, but I don't want to eat up all of your evening because I know that it's probably late over there for you and it's early over here for me. But thank you so much for joining us. This has been so much fun. Thank you.
Thank you too. I appreciate it.
Absolutely. And we appreciate your time also. And the audience, we appreciate you for tuning in. I want to give a special thank you to Zvonko for joining us today. And thanks to our audience. I'm just going to gush over you all again for tuning in. And please join us on December 7th for the next Open Info Live, where we'll get a recap of the virtual project Teams Gathering, PTG, that was just held back in October. And don't forget, if you have an idea for a future episode, we want to hear from you. So send your ideas over to ideas.openinfolive.live, and maybe we'll see you on a future show. You know, who knows? Thank you so much again, Zvonko, for coming. And thank you, audience, once again for tuning in. Hope we see you on December 7th. And I hope that you have a happy holiday. Thank you all so much. Bye, everybody.
Bye-bye. Take care.
Bye.